Yep, off you go.
Okay, if you don't mind me asking, what is your date of birth?
Sorry?
What's your date of birth?
13/2/25
Okay, thank you. And where were you born?
in Ogmavale.
Okay, so what was life like as a 16-year-old in Ogmavale?
As a 16-year-old?
Yeah.
Well, as a 16-year-old, I was on the last year in school. I had done my matriculation, they called it then, in 14. It was you started at 11 in secondary school. It was before it was a grammar. And you started for some reason in Form 2.
Okay.
So you did 2, 3, 4, and when it was in Form 5, you did your school certificate or matriculation. And then, if you could stay on another year, you did what they called higher certificate, which I did, and I did it in botany, zoology, chemistry. You just did 3. And after that, I left school, and it was during the war, so I had to have a job. Well, I didn't have to, but I applied for a job, and for some reason, I went to London.
Okay.
Working for the Admiralty Research Laboratory as a lab assistant. So I went up never having left before. And I can remember technology then. Nobody had a telephone. So when I actually got to Teddington in Middlesex, where the Admiralty Research Laboratory was, I had to go somewhere to find somewhere to live. I didn't know anybody, but my father did come up just for a day. So we had to go to, it was an employment office where you could find somewhere to live. They could have a list of names. And I had to phone somebody. And I can't believe this. That's the first time I'd used a telephone of any sort. So that's an advance. And then after that, I started work in a group called, at that time, Optics Group. And they dealt with things like telescopes, aerial photography, and rangefinders. They tested rangefinders and tested new ones. A rangefinder, all the gun placements in the country, when they shot at aeroplanes, they had to know how far away they were. So rangefinders was an instrument that you could find out approximately the distance. So at that time, it was all about trying to get things done quickly, calibrating things, sending them out. And there wasn't much money about, but you had to do everything from scratch. But now then, what comes after that?
So how did you get a job? How did you see it?
Yes, that's the point, isn't it? I think you just went to a labour exchange. But in any case, when you were 18, you had, you either went in the forces or they directed you to a job. But it wouldn't normally have sent you to London. It was just that I felt I wanted to go.
So you were using all this technology all of a sudden?
Yeah. The main part, laboratory systems, you see, this was, when you think about it, it was pre-computers. So everything had to be done by hand, calculation. And I did maths, so that's mainly what the lab assistants, my job was collating figures, sort of statistics and working out things. There was a process called numerical analysis. I don't know whether you've heard of it. That was sort of ways of solving equations in different sorts of ways. Say they were trying to make a new lens, for instance, and the curvature. You had to have the figures, the curve had to be right. To work it out, there was lots of calculations. And there were different methods of shortcutting. There was one called relaxation technique, it was called. And it was Professor Southwell had invented it. You were faced with a huge, very complicated equation, and you looked at it and you decided perhaps that's the answer, that, and that, and then you tried to work it out using guesses. But sort of, well, that sort of thing. And so rangefinders, lenses, they were tested rangefinders. There were a couple of soldiers seconded from the army on the roof of the building, testing rangefinders with lots of readings. And you sort of recorded that and found statistical analysis to get an answer. It's hard to think about it because there's no calculating machines. The only calculating machine we had was called a Brunsviga, and it was a German one, and it was a sort of thing that you wound like a sewing machine.
How big was it?
About that big.
Okay.
Before that, you see, there were lots of business machines, Hollerith machines, punch card machines that they used for business. But computers had only just started to be developed. In America they went on, but in this country they had to put on hold because of the war. What else? Just ask me a question.
So you hadn't used technology back at home before?
No, it was just figures, maths.
Yeah.
And you knew a little bit of physics, and you knew a little bit about lenses and a little bit about telescopes, but not really, But as you worked up, you learned an awful lot by doing it. And in the end, it turned itself into a mathematical group. And there's optical computing, all sorts of different techniques leading up to. But when you think about it, how, if you were faced with an equation, you just had to do it by hand.
Yeah. Okay. So what was your workplace like?
It was a large building. The Admiralty Research Building was quite a large building with different departments. There was an engineering department, and there's 4 floors, quite a big building in Teddington. And next door was the National Physical Laboratory. Have you heard of that?
Yeah, I think so. What were they doing?
Well, that was mainly basic research. It had always been there. Or they did all sorts of things. What did they develop? They did acoustics. When they built the Albert Hall, the acoustics was tested in an NPL, it was called. There were lots of top scientists who used to work in NPL. And they had the wind tunnels to test designs of ships, wave tunnels. It's a huge place. Yeah. So the ARL, Admiralty Research Laboratory, worked in conjunction with them, Okay. And I can remember, in fact, soon after I started work, going across there, and in the wind tunnel, put to one side, was the model of the Severn Bridge that was going to be. Now, this was in 1943. So they had actually tested this thing, but it had to be put to one side because the money was for the war. So they did the atomic, the standard clock was there, the standard measurement, the yard. That was where everything like that was kept. This isn't very interesting, is it?
No, it is.
And while all this was going on, you see, there were people still trying to carry on the research they'd been doing beforehand. So, for instance, the underwater camera,
Okay.
that's developed in ARL by, what was his name? Dr. McNeese, his name was. That kind of thing.
Yeah.
Because they did aerial cameras. We used to analyse pictures taken from planes, you know, that kind of thing. And because lots of things needed figures, maths, to be worked out. And we were the sort of working office. People would come in. I tell you what sort of thing. Barnes Wallace, you know, the bouncing bomb thing.
Oh, yeah.
He had lots of equations to check things. Well, they were done in our group. We didn't really know much about the bomb, but it was a sort of working group. Whereas today you would phone up and a computer would do it. We were all working away at little figures, which was quite interesting.
Yeah.
But there was somebody, fibre optics.
Yeah.
That was another thing that was developed as a sort of sideline
Yeah.
to some, with Dr. Knight. And that started off by just illustrating instruments in aircraft by night. That's how it was started off. And
Can I ask one thing? Ask Heulwen, how good was she at maths in school?
Yeah.
Because this sounds like the first human computer.
Yeah. So how in depth how good at maths were you? in
not
school?
terribly.
Because you sound like
I tell you what, when I was there, it was just ordinary GCSE. Maths was quite different to what it was now. But soon after, we went to evening classes in Kingston Technical College. And because I needed maths, it's now Kingston University, but then, and I did applied maths, pure maths, physics and chemistry into BSc. So, but you can't compare the maths with what it is now.
You must have been using some complex.
Yeah, equations, calculus,
Okay.
a lot of trigonometry, which you
Yeah.
don't do anymore, do you?
Okay.
What is trigonometry?
What is trigonometry?
Yeah, well, theorems, you know, Pythagoras' theorem,
Yeah.
you know,
Yeah.
well, that's a bit of trigonometry. And you worked out causes and sines. What do you do instead then? You see, you can't compare it at all.
So you,
I suppose it's more like statistics than anything else. But you know, quadratic equations. Do you do those? Do you? Well, you know, very, very, very complicated things, sets of those. But it was before matrices. You know, that was pure maths, but that was a bit higher up scale.
because I've never known what you'd use that equation for in the real world. So what sort of equation?
Yeah,
would
and I
you
was
use?
just trying to remember now. So, say you know, designing something now, you do it on a computer, don't you? The shape and the actual dimensions of the thing. Well, in those days, you had to take, you know, you had say you're the centre there and you wanted a particular curve. Well, you had to work out an equation for that point there and back again, and so to actually draw a graph for the shape. Then you translate that then into instructions. It's hard, it's almost impossible to.
So, could you give me an example of this, of what you'd use an equation to work out, or what object or...
Yeah, let me think very hard. Oh, I can't really. Apart from, oh dear me, this is difficult. A lot of it, you'd have a set of figures, take readings, say you wanted to find the exact distance now of a rangefinder, you look through to see how accurate it was. You had a point where it had been accurately measured, like a church steeple, which had been surveyed, and you knew it, the distance from where you were to within, say, 2 feet.
Okay.
So then you'd take a set of readings on this instrument you were trying to calibrate or test, and then you'd work out this numerical analysis thing with a medium and a mean, and it's like statistics. You don't do statistics.
Sounds complicated.
It's impossible to... So, if you were doing that now by computer, say you were designing a... what should we say? A sort of shape.
Okay.
How would you do it?
Oh, sure.
On a computer, would you? You do it visually.
Yeah, you do it. You maybe do it in a computer.
Yeah.
And you wouldn't really know how it's done because the computer does it for you.
Yes.
And in a strange way, it seems similar that these guys who were doing the calibration didn't really know what you did, but you just worked it out.
Yeah.
There's the
Yeah.
answer.
Yeah.
Isn't it really strange? The
Yeah.
comparison is quite close to how the internal workings of a computer
Yes,
these days.
yeah.
It just does it.
Yeah.
So
But you see, when the adding machine and things in business, that's what they were always used for. A firm would have all their wages would be on. Have you heard of Hollerith machines, punch card machines,
I've heard of them. I don't...
comptometers?
No.
Well, it's like well, it started off with the looms. How it all started off. The Babbage. No, Babbage engine. Well, that's how computers really started. Oh gosh, this was in 1700 and something. Anyway, punch card machines was a big machine, and with a lot of punched cards. Now, in a computer now, you have a set of data, say, and you want to find out how many people were born on the 13th of February. You just punch in your program, didn't you?
Okay.
And it prints out. See what I mean?
Yeah.
Well, punch card machines were the same sort of thing, but they were mechanical. You had a stack of cards that you punched holes in. And then you could put them through, and the same sort of thing. And that's how firms used to work out their wages on big adding machines. And you'd probably find a picture of them in there.
Yeah.
Comptometers, they were called.
Okay.
And adding machines, you said, turn the handle,
Yeah.
and it added up for you. And then multiplication and division, it would do it mechanically for you. And you'd read it off. But that's how sort of computers started, you see. Because while all this was going on now, there were still people in, say, NPL developing computers, and in Cambridge. And the very first one there was called EDSAC. But in America, with no war,
Yeah.
they were very much advanced. So that's where the first scientific type computers were. By English Electric in, not English Electric, IBM in America. So, by the end of the war, by about 1946, 47, where it wasn't so important to shoot people down and shoot missiles, and computers were beginning to look more interesting, and in the NPL now was the first computer called the ACE, which is now in this Natural History Museum or Scientific Museum. But technology now is all. Have you heard of degaussing?
No.
Oh. This sounds crazy now.
Okay.
A lot of things you try to stop people shooting down at you, and try to stop airplanes bombing the right sort of targets. So there was this thing called degaussing, which virtually was surrounding the thing on the ground with a magnetic field,
Wow.
like had wires and wrapping it up. So it would divert, divert the shooting. They wouldn't be able to identify the exact position because of the degaussing would be stopping the instruments like sonar and radar. That was developed for the same reason. Just try and stop torpedoes getting their target. There's a great big section came down from Scotland, the torpedo experimental establishment. That was they were all it's all tied in. But I knew I would be able to help. It's too big.
Yeah, it's good.
Brilliant.
But
Amazing.
what else? Or somebody else they developed in circuit things. What do you call those things that you put in?
Circuit boards.
Yeah, there's all sorts of things, and crystalline things, and like SIM cards now, I suppose. It was the start of it all. And this, like the Enigma machine.
Yeah.
Well, after they'd solved that, and after there were all those clever mathematicians, that they came to establishments like NPL and ARL, and to develop computers. Like Alan Turing, and that's what he. So that's after they'd finished with the war business, which had to take priority. They were then free to carry on with what they were doing anyway.
So at that time, did you know anything about what was the Enigma machine or anything in relation?
Only vaguely. It was before. It was before. I 1943. I was up there, January. The Enigma machine was really before that. We knew about it.
Yeah.
Because we knew some of the people who came from there then,
Really?
like Alan Turing and Jack Good.
In what way did you know them?
Well, they came and they were doing their own sort of work in the establishment.
Yeah.
So we didn't know them, I'd spoken to Alan Turing and met him,
Wow.
but not friends.
No.
But, if they wanted some simple sort of maths done, they'd phone up maths group. Can you do this, this? And you say yes, and you'd add them up. And it just, we're all working together.
Well,
The other thing was, you heard of the frogmen?
no.
Well, frogmen were, I think they were actually in the Navy, but there were 4 of them. They were swimming underwater and sticking bombs on the ships.
Okay.
They,
Yeah.
blew up a lot of German ships in harbours. Have you heard of Buster Crabbe?
Yeah.
I knew him.
Well, I've heard you mention.
Yeah. But that sort of thing, that it had to be worked out then, the direction,
Yeah.
and which ships were there. The other thing was beginning of direction finding, it was called then, which is sat-nav, I suppose, now. That was done from, so everything worked together. The Greenwich,
Okay, yeah.
he was called the chief something of the Admiralty, and this was direction finding station where there was all sorts of, was direction finding for aircraft to find their way and to track.
Yeah.
Same sort of thing as sat-nav is now, But it was all sort of geared towards stopping killing
Yeah.
and stopping bombing and bombing back. So there were all sorts of direction-finding stations. There was one down by Nash Point, actually. Have you heard of those?
No?
No.
No. Fascinating.
Because radar, that's when radar was in its infancy. It was developed. Sonar, underwater direction, the torpedoes. What else? Things like that. Let me think. Oh, aircraft carriers. You had to work out that. I can't remember how we did it or how I did it. But, aircraft would land on the aircraft carrier deck.
Okay, yeah.
And there'd be a wire, well, not a wire, to stop it. Well, that had to be worked out, the strength of it, and how it should be strung across so that the aircraft, you knew how heavy it was, and it would come down, and you had to have something strong enough to stop it shooting off the other end.
Yeah.
See, this kind of thing is all a bit hazy.
So you were working out these with a group of people?
Yes, I mean, we were doing what we were told in effect,
Yeah.
But I should have kept my numerical analysis, all my books and things, because they were definite techniques.
Yeah.
And have you heard of actuaries?
No.
Oh, actuaries, the people who, insurance people, they like, the possibilities, permutations, and things. Well, they must have actuaries. Look it up. But that sort of thing, you see, it was all,
Yeah.
it was like hit and miss quite often. You tried this and it didn't work, so you tried something else.
Yeah. So when you came back, did you ever come back to visit? No.
Well, we worked 5.5 days, and we had 10 days leave a year. So, and you did have Christmas Day and Easter Day. So I only came back about 3 times a year. That's all you could.
Were you asked what you were doing
By people.
Yeah, by people.
Yeah, but you couldn't, just hard to explain.
Yeah. So what would you say?
Oh, I would just say we're adding up figures and this, that, and other, and testing things. I mean, people, if you said you were testing a camera, they could understand that.
Were you allowed to say what you were doing?
Not really. No, there were some things that.
So would you have had to sign something? Say.
Yeah, you signed the Official Secrets Act. Yeah. When you went, and also when you left.
Yeah.
I got it upstairs somewhere. Only a bit of paper. But there were all sorts of different departments, you see. There was a night adaptation. There was a funny little department in a hut, manned by about 5 or 6 people, on diets of carrots to test pilots' dark adaptation of fighter pilots to see if carrots helped. So some of these half a dozen orange-looking people, because it didn't. If you ate enough carrots, you did. In a way, it was quite funny, but it got results. I'm just trying to think of something in NPL which you would definitely have heard of. You can imagine now, this wind tunnel is a huge affair, and a water tunnel. I mean, if they're designing a new submarine or a new warship, you had to have it. They had a proper model of it by skilled model makers, and tested against waves and wind speeds, and to get streamlining right. So in a way, it's all these sort of things now would be done on a computer, wouldn't it? see, computers were starting. In fact, the ACE, we went over and I could, showed what to do. And it was very, very primitive. But there was fantastic excitement. You had to write there wasn't anything there. You had to write your own subroutines. You see, if you wanted to have square roots, for instance, I mean, there was nothing there. You had to code it.
Yeah, how would you do that?
Well, you had to use binary language for a start.
Okay.
And it is all, well, it's just on and off, isn't it? You see. You have a signal, and if it's on, it's say 1, and if it's off, it's 0. And let me think. Well, you just fed instructions into the computer, which said something like, what should we do? Add up. You fed in one thought, then you had to say, add that to that one. The valve would be either on or off. If it was on, you could add it. If it was off, you could take it away. And it's impossible to explain.
So you had to learn binary language?
Yes, you had to learn binary language, yeah, which was quite difficult.
Yeah, I can imagine.
Because
Yeah.
when you were really doing it yourself, you had sort of 1 note, not 1. And
See, I've never been able to understand how that would make a computer do a certain instruction.
yeah, well, see, there again, the instructions were actually put in by punch tape,
Okay.
you see. They fed through. What can you think of anything that you could compare that with? Like, seen old musical boxes, you've seen pictures of cylinder things? Well, that's the same sort of thing, you see. You feed in a piece of paper with lots of holes in, which would engage in different bits. And you'd end up...
There's what do you call that? Cylinder is an organ type thing, isn't it?
Yeah,
And this piece of paper with holes in particular places revolves,
yeah.
and every time a little hole appears, it either pushes or and turns a note on.
A note on, you see?
Plays a symphony for you. But to make the holes in the right places
Yeah.
is the skill, I guess.
Now imagine that now as a scientific thing, where instead of things sticking up, it would be electrical impulses. See?
How
On and off valves.
How did you expect that one day it'd be so it would go so as complex?
No,
as
not
that?
as quickly, no. It is extremely exciting right in the beginning with computers. I can remember people in the ACE computer in going over there once, and they were terrific excitement because they'd managed to have a program that did square roots, and they were really excited.
Yeah.
But that was happening very, very quickly then, because America and Cambridge, they could have all their resources then onto computers, you see. In fact, Admiralty Research, we had the first working computer in the civil service, a little, and it was a huge room it was called, it was an English electric one. And I don't know, half of it wasn't really used for all that much in the beginning, but some of them were. They were starting to do really scientific stuff. But it was in a room about the size of all this house, air-conditioned.
Wow.
And this huge, huge, huge machine. You must have seen pictures of the Enigma stuff. It was like that. Huge machines. So compare that with what you've got in your hand now. and you can't.
No.
So as soon as that started to happen, then it went quickly then, and started to be commercial, and it came out of the scientific labs, and firms managed to get computers, and they started to use them for research, and after a few years they started to use them for business, and that's when it all started to take off actually. This was computer language, COBOL.
Oh, okay.
Have you heard of
I've
COBOL?
heard of Grandpa.
That was one of the first business languages. Well, that's when all the money then could be poured into.
Okay.
And before that, there was the scientific equivalent of that was, I've forgotten, COBOL. Oh, I can't remember. But there were two distinct progresses then, business and scientific. But lots of firms started off then making computers. And first there was, so you had to do it in binary language, and then they started to experiment and ended up with simple code, it was called. So instead of having a punch tape with all these binary things saying add this, add that, you had simple code which just says add.
Okay.
But you put in the computer and that started then, it did it for you.
Did you ever think that having the power of what the computer was, that like people's jobs would, computers could do jobs?
It started, you began to realise after a few years, especially when simple code came, and that meant that you didn't have to know about machine code or anything. You suddenly realised anybody could do it. You could press a button, and as long as somebody in the background had done all the programming, it could be used then by somebody who didn't understand what was inside. See what I mean?
Yeah. So, were you scared that maybe the computer could do the job, or were you always giving it new?
No, it was. It didn't think of that aspect of it at all,
Okay.
because, I mean, the computers in those days needed people
Yeah.
to, to do it. But then gradually, as the years went by, you could see that there was robotic things and automatic, and it went on and on from there. Because in the end, and this was overshadowed all the time at the end by the atomic bomb, you see.
Yeah.
There was a lot of resources doing that, and then they all came back. So I'm rambling now. I can't, it's difficult to remember. I can remember. Let me think now. What is involved? The underwater camera. I mean, there were some things that researched which were useful, and you could see like the underwater camera, and lots of things like that was going on. But in the end, the mathematics group, it was, they were testing bombs in Easter Island and the atomic bomb, and we ended up having to do lethality calculations, and a lot of people like me, didn't like the way it was going, so that's when, and London was horrible then.
What's lethal?
Well, working out how many people could be killed by, missiles. Missiles started then. And I didn't like the idea of working hard on missiles, which are still going, aren't they? They haven't changed much. But, other thing, I don't know. establishments all over the country, you see, for the forces, there was dockyards, you know, they were doing research on ships and submarines, and in a way it was all useful in the end. But when I left Admiralty, I went first to Standard Telephones, because they were building their own computer called Zebra. And this was one of the new computers, you know, a firm could buy. They were developing that. And that's right, I was on a thing at Swiss aluminium plant up in the Jura Mountains. Because this was, it's Jura. Because they wanted something worked out to automate the process. And they had a program to do this, which I used to commute to Lausanne University for a little while. And it was just automating, you know, programming the process so that a computer could do it, that sort of thing. That's not very clear, but...
So, how long were you working in the Admiralty?
43 years. About 19 years. Then I got fed up with London, so I came back. So I worked in Newport as the job back in this area. And after 2 years, they decided to move back to London, so I left.
So you at Newport, that's where you were doing the with the Zebra.
Yes, that's right. Yeah.
And then when you went back to London.
When they went back, I left, and I went then. Had a job with the electricity generating board. There again on test results, you know, and that was quite different. They were just testing power stations and things like that, working out processes. Everything had to be. When you think about it, all these processes have got mathematics at the back of them. Working out, you had to know. You know, you do a test. Well, you have a set of results. What do you do with them? It's got to mean something. So that was the electricity generating board. Remembered, there was the opening of Aberthaw Power Station and Eskmouth Power Station. And then, horror, it was a nuclear power station. So, see, it's all happened. You think it's happened quickly, well, it has, I suppose.
Yeah.
But when you think back, technology's always happened quickly, isn't it? I mean, that's within Newton's time. In a lifetime, then all sorts of sciences were developed. And you haven't heard of Babbage? Oh, well, there was a project, History of Babbage Machine. Look it up. I'm just trying to think of something interesting.
What else do you need to know?
So you went from living without any technology to suddenly developing the future of technology. So now today, what sort of technology do you use?
Do I use?
Yeah.
As little as possible.
Yeah.
I do. I mean, I don't know how that works.
Yeah. But
Because my job I really enjoyed more than anything else was the one that didn't have it, was in the university sort of admin, you know, dealing with students and people. That's the job I really, you know, ended up in Cardiff. And I enjoyed that more than the others because in the beginning it was exciting. But quite often you were working, in the beginning now, you working on all these figures, and it was hard work. You had to be accurate, and if an error crept in, you had to start again and this sort of thing. But you didn't really know what it was going to be used for. That was the trouble. And I think... DSD-9, naval signals. Now that was interesting because that again was this direction finding, and it involved instruments that told you, you know, you could pick out targets and all sorts of things. Well, that was underground in London. Do you know the Citadel? Underneath. That was offices of naval signals. So they were having signals from all over the world. Well, your father was involved, wasn't he? In
On the master.
yeah. See, it's all coming together.
And he was saying something similar to us the other day about how all this technology, because of the war effort or because of the nuclear arms,
Yeah.
all this, these highly intelligent research centres, once the war finished, all that spilled over into businesses, into life, and other byproducts, sort of.
That's it, exactly, yeah.
I remember him, he was saying one of the only good things that came out of the atomic energy research was a portable X-ray machine, really.
Yes, that's right,
For humanity.
Yeah.
Apart from working on the bomb, that's little things like that, because there was high concentration of scientists.
Exactly, yeah.
How have you seen technology, you know, good and bad, develop?
Well, good is obvious, you know, there are all sorts of good things. Bad is dangerous, I think, because you could see it happening. When, you know, they don't know where to stop. I mean, there's no reason why they should have horrible, you know, worse atomic bombs, you know, there again. It goes too far. And they're going to, you know, like clones. In all aspects of science now, it happens. Like genetics and cell theory and all that sort of thing. In the end, they create life. Because they think they can do it, they're going to. And I think that's when it should stop.
What is that boundary line then?
Yeah.
What is the line which...
Well, as far as some scientists are concerned, there isn't a boundary line.
What is your boundary line?
Yeah. Oh, my boundary line? Well, like the lethality thing is... Well, that was one real reason why I wanted to leave Admiralty. Because everything that they were doing was for war and stopping, you know, power and stopping other people doing what they wanted. And I thought, well, if all the countries in the world are doing that, it's like in the Middle East, isn't it? Whereas good research didn't get the money.
So what would you consider good research into?
Well, good research, medical research.
Yeah.
Just environmental stuff, you know. You know, if they could stop, well, like smallpox, they've eliminated that, more or less, haven't they, from the world. If that, you know, if all these clever scientists got together instead of doing bombs and gun sites and new guns, got together on medical research, I'm sure they could eliminate lots of things. But there we are. But as far as your maths is concerned, and my maths it's two different things altogether. I had a friend who was a pure mathematician, and the reason one went to America. And this was end of the war. And he did things like matrices and pattern, what do they call them? Sets. Do you know? You don't know those now? But I didn't understand the first thing. I didn't understand the basis of it, and that was pure maths. And there's loads of those about, but they must have been useful for something, but I just didn't understand that.
What do you use your tablet for? Well, you've had some questions about the tablet and today's use. You think? Yeah.
So, with the tablet that you've bought, what do you use? Why? First of all, why did you get it?
Why I got it? Because everybody else had one and everybody's nagging me. People like Thomas.
But what about it did you want? What were the factors?
Well, curiosity really, but the only thing I use it for is to look things up.
Yeah.
Instead of getting down an encyclopedia and reading it, which I still prefer to do, I look it up. And then it goes funny on me. It went off.
So you use technology as opposed, I'm not saying that Clear doesn't, but a large part of Clear's usage of technology is for entertainment.
Is what?
Entertainment? So
Yes.
But you, it's not true with you, yours is more educational.
It is,
information.
yeah. Given the choice, I read rather than watch television, and put it that simple.
What sort of stuff do you look up then?
Oh, half it, just the weather. I find that very useful. If it's a nasty day and I've got to go out, I look to see which hour is the best. And odd things. I looked up what was on, restaurants, menus, pubs, travel things. I don't use it for anything really, but as for entertainment, I got a little television, and half the time I don't have it on. So your entertainment is sort of all this technology in the past has come to be just entertainment. Well, fair enough. I mean, you think it's happened quickly, but has it? I can remember the first bit of colour films.
How does that make you feel then? Like you said, all the work and the effort and the skills and the intelligence has ended up predominantly being for entertainment.
Yes.
You said that rather ruefully, as if.
Yeah, and I think, thinking back, people, they thought it would be more important than that. It is important to have entertainment, but a lot of it is... and the use of modern mobile phones drives me potty. You go downtown and there's somebody coming along. I often think, well, the world doesn't mean anything to them. The world is their phone, and it saddens me. It really does.
So you never thought when you were developing all these things that it would be such a big part of everyone's life?
Oh no, I'm sure, no. And I'm sure that, I wasn't a scientist, but the top people, I'm sure they didn't think so either. A lot of people had very high ideals in those days. Like Alan Turing, he killed himself in the end, but you heard them talking together, and they were going to do great things for humanity, It just didn't happen. Because that's how men are, I suppose, what humanity is. Yeah, lots of good things. Like, well, even the acoustics in the Albert Hall it was good. And they, you know, like they developed bridges and things. As I say, the Severn Bridge. That had to be tested, didn't it?
You know, you said it saddens you when you see people walk around town like this.
Yeah.
Because the world isn't their reality. And this.
Yeah.
It saddens you, I guess, because you know what the world offers. And what are they missing? What does it make you sad for them? What are they missing out on?
What they're missing out on.
Yeah. What are they missing out on then?
Yeah. Well, I was walking, I was walking down the road, and there was the most beautiful bird singing away on the top of a tree. I could see it. And I was looking up like this, and then it's coming towards me with this man like this, and I thought, well, I thought to myself, now should I put my bag out and let him trip up? And nearly did. Because he is completely unaware of anything. He's like this. And he was coming right at me. So I did dodge out of the way, but but he missed all, you know. He misses so much.
What is that? What's the significance of the bird singing in the tree to you then?
Well, it's there. I don't know, it's significant to me.
In what way? What,
It's beautiful. And it's there. And the colours are there, and the trees are shivering, making noises. And it maddens me too, and mother's going along like this, and the kids are trying to talk to them, and they're ignoring them completely. That annoys me. I'm a Luddite. Do you know what a Luddite is? Well, I'll give you a history lesson. A Luddite was when they started, long time ago, having machines, agricultural machines usually, they thought would take over their jobs, you know, the ploughs and the combine harvesters. Why were they Luddites? Was it the Mr. Luddite? They were called Luddites anyway. They were trying to, riot to stop the machines. It didn't happen, but it's still happening, isn't it? The people.
You've lived through you were talking about the agricultural revolution and the industrial revolution. I guess you've lived through the technology revolution.
Yeah, I think so, yeah. A lot of things that people did and were important are now taken over. Think of something.
I think you had. The beauty of sight and sound of the bird and the tree glistening. Just the beauty of life.
Yeah, I mean it's still music, isn't it? I mean I don't mean pop music now because that's technical, isn't it? But I think there's a growing trend for people to want to get into the country, away from things. I don't know whether you feel it. Have you noticed?
See, we love to go.
Yeah.
That's where up Moyle, up Buch.
Yeah, Bulch.
Yeah.
Bulch.
Beautiful walk. Stunning scenery.
Imagine what it was like before they planted the trees. I can remember. Rugged and stony. We used to walk quite often from Nantamore over to the Rhondda to Treorchy because I had a great aunt over there. Used to, but there weren't any trees then. It was just paths and mountains. And on top of the Bulch, there were 7 lakes. The trees drank them all up. They're not there now.
Did they?
No, 5 lakes. Not huge, but they were there.
Yeah. Should we have a cup of tea?
Yes, do you want a cup of tea?
Fantastic, that's it.
Yeah.
Fantastic, fascinating listening to you, Heulwen.
No, I'm very disjointed. It's too long ago.
No, it's really interesting.
It is.
Yeah.
I keep thinking of things.
But the comparison to the internal workings of a computer or a calculator stuff and what your team were doing are very, very similar. But members of
Have a look in there.
members of Heulwen's team had a moral conscience, and you felt, well, when we're working out how many can you kill more by doing,
Yeah.
that's when some people stop. In a computer,
Yeah.
there's no
No.
moral compass in there.
No.
So
Yeah, but-
it's I think that's fascinating.
But it's difficult to